Okay, so you may have taken a look at our notes and seen that we're doing arithmetic sequences and series today, which is just patterns. All right, so it's taking something that you know a little bit about and just going a step further. In the warm-up, it says, what is the next term in the sequence? What did you guys say?
22.
Why 22?
Good.
Good. So they make it confusing with starting with some negative numbers, but if you do see that you're adding 8 each time, right? So if you add 8 one more time, you get to 22. Right? So that kind of pattern is, I mean, you didn't deal with negative numbers as much in elementary school, but in general, that kind of pattern is a pattern from elementary school. Now, we're actually not going to do more complicated patterns today. Like, there's not going to be patterns where there's like 2 things happening or any multiplying or dividing patterns. But there are ways that this kind of problem can be harder. And we're still going to investigate those. This is a formula for an arithmetic sequence. So a sub n would be the nth term. So if this is a sub 1, that would be the first term. A sub 2, a sub 3, a sub 4, and then this one here is a sub 5. So if I'm trying to find the 5th term, if I didn't know all of the terms in between, I could start with the first term, which is a sub 1 negative 10, and I'm going to add d. d is the amount that you're adding each time. See how I'm adding 8 each time? And I forgot that I added it one more time here. I add 8, not 5 times, but 4 times. You see that? Because here's my first number, and I add it once to get to the second, and then another time to get to the third, and then another time to get to the fourth, and another time to get to the 5th. So I add the 8, which is my d, and I don't add it 5 times. I add it 5 minus 1, so I add it 4 times. So even if I didn't know the negative 2, the 6, and the 14, if I just knew it was a pattern where I'm adding 8 each time, I could figure start with my first number and add 8 4 times, and then I would get to 22 as well. So this formula right here is something that's going to be useful as we move down here. A sub n is the value of the nth term, so in this case 22. A sub 1 is the value of the first term, in this case negative 10. N is the term number, so this is the 5th term. And d is the common difference, which is how much you're adding each time. So common difference is how much to add each time. Time. Okay, that was hard. That's supposed to say time at the end. Sometimes it's a subtracting pattern, and that's okay because you're just adding a negative number. So if the numbers are going down, just think of your d as a negative number. All right, in example 1, it says, decide whether each sequence is arithmetic, and if yes, find d. Find out how much are we adding each time, okay? So if I go from negative 3 to 1, I added how much? Negative 3 plus what gets you 1? 4, right? And if I continue adding 4, you want to check each step. Do I get the next number? Yeah. So this is a yes, and d is 4. You have to be careful because sometimes something will work for the first 2, and then it doesn't work after that. So check and see if you can find a common difference that you're adding each time. And then if it's the same common difference, then it is arithmetic, and you'll write yes and what d equals. And if it's not the same common difference, you'll write no. Remember, I'm not asking you if it's a pattern, because there's lots of patterns that aren't adding patterns. I'm asking you, is it an adding pattern? All right, the first one, was it yes or no?
No.
It was no, because first we add 3, and then we add 5, and then we add 7. And some of you notice that there is some sort of pattern in here, but it's not an arithmetic sequence because we're not adding the same number each time. So this is no. And then how about this one?
Yes.
It's an adding pattern?
No.
What kind of pattern is it? It's multiplying. So next class we're going to learn about the multiplying patterns, but it didn't ask that. It asked if it's arithmetic, and to be arithmetic, you have to be adding the same amount each time, right? So this would be a what? Yes or no?
No.
No, good. All right. Use the rule to find the 10th term of the sequence. So that means n equals 10. And all we have to do is substitute 10 for your n. So a sub 10 is what we're finding. That means the 10th term. 6 plus 10 minus 1 times 5. Now the TI calculator knows order of operations, so if you've put the 10 in for your n, then you can substitute this all into the calculator at once. It will do the correct order of operations for you. All right, so this should be 51 here. Questions? Yes? Oh, you're not going to write that. That's a good question. So you just start with the 6, okay? All right, list the first 5 terms of the arithmetic sequence with this rule. Now, you could put in 1, 2, 3, 4, 5 for your n. Like, you could do that and it would work, and you would get the first 5 terms. But you can also kind of break this down, because we know that when we have the formula written this way, a sub 1 is this first number here. So we know a sub 1, the first term, is negative 8 equals negative 8. And we know that d, the amount we're adding each time, is 7. So if I want to write the first 5 terms, I know the first one's negative 8, and then I add 7 each time. So add 7 to negative 8, add 7 again, that's one way to do it. If you get stuck and you're like, I don't really know how to break up this formula, that's okay, because you could just put in 1 for n, get your answer, put in 2, put in 3, 4, 5, and it'll be the same thing. Same list of numbers. Questions on that? Okay. All right. Example 4. Write a rule for the arithmetic sequence where a sub 1 is 8 and d is negative 4. So I want you to try this. What you're going to do is you're going to take the formula up here and substitute 8 for a sub 1 and negative 4 for d, and that's it. Nothing else. They're just telling you these 2 values. Everything else is going to stay variable. Write that equation, compare with the neighbor. When you write your equation out, add parentheses on your negative 4 so you don't think you're subtracting 4. You're actually multiplying by negative 4. All right, do the next 2. We're just writing rules again. But you need to know what is a sub 1, and then what is d, and then you can write the rule. Let's see how you did. So for the first one, your a sub 1 is your first term, which was 8. And then your d, you are adding 9 each time. And so then your rule, we're copying it from up here. A sub n equals your first term, 8, plus n stays a variable, n minus 1, and then times d. If d is positive, it's not essential that you put those parentheses there, but it's just a good habit to put them there because then you won't forget when d is negative. Okay, in the next one, a sub 1, that's your first term, 31. D is how much you're adding, and since it's going down, d is going to be a negative number. Is it negative 7? Okay. So a sub n equals 31 plus n minus 1 times negative 7. All right, what questions do you have so far? Okay. When you're ready, turn the page to the back. I want you to look at the first problem. And it's a pattern, and I'm telling you it's arithmetic, which means the pattern is an adding pattern, but you could be adding a positive number or a negative number. Is it okay if I flip it? Okay. So I'm going from negative 7 to 3, so am I going to be adding a positive number or a negative number? Positive. Positive, good. And I need to be able to find this number here in the middle. because there's only one number in the middle, there's different strategies that might work. I want you to just take a minute to see how would you reason that out. And then after you do that, I will give you a general strategy that will work for any problem, especially like these problems where there's two. But think about this first. Raise your hand if you want to share an answer for A. It's okay if you don't have one yet. Nick, what'd you get?
I got 5.
So you said that you were adding 5, right? But you actually put a different number in the middle. What was it? -2. Okay. So Nick saw that by adding 5, you could get to -2. And then if you add 5 again, you get to 3. And how did you think it up? You just...
Pick a number that's in between.
Okay. So -2 is a number between these two numbers, and then you found that you add the same number each time, and it works. And that's good. Did anybody have a different method for that one? Okay. Sydney, can you explain your method for this one?
So there's 9 numbers in between 5 and 14.
Okay. Okay. There are 9 numbers between 5 and 14, right? 14 minus 5 is 9. And then she divided it by 3 because you end up adding 3 times. 1, 2, 3. And realize that you're adding 3 each time. And these are really good methods. And if you want to use those on a quiz, that's great. But if you would like a method that's going to work, even if you're like adding 5 things in the middle, here's another method. If you feel solid on this, it's okay. But here's another method. So it's kind of related to what Sydney was talking about. We're adding a number here. And I'm going to call the number D because that's our common difference. We're adding it 2 times. See, I added the D 2 times. So if I start at -7 and I add 2 D's, I should get to 3. Let me zoom that a little bit. Okay, so I added the common difference 2 times. I don't know what it is. And I start at -7 plus 2 of those D's, and that gets me to 3. And then I just solve this. I'm going to add 7 on both sides. 2D equals 10. And then divide by 2. And that gets me D equals 5. So that means I'm adding 5 each time. So if I add 5 to this, I get -2. I want you to try that method on the next one. Okay, so again, we're adding D twice, right? Plus D plus D. And so it's going to be 24 plus 2D equals 16. And then subtract the 24. And then divide by the 2. So I get D equals -4. And if I add -4 to 24, then there's 20. In the third one, we actually add D how many times? 3 times, right? And that's why Sydney said that when she found that there was 9 in between, she had to divide by 3, right? It's related. So here you're going to have 3, you're going to add D 3 times, and then you're going to come up with what the D is, and then you'll figure out the numbers in the middle, okay? So go take a minute and do that, and then I'll come around and see if you need help. All right, so here we added D 3 times, between the 5 and the blank, between the blank and the blank, and then between the blank and the 14. So it's 5 plus 3D equals 14. Subtract the 5 and we get 3D equals 9, and divide the 3, we get D equals 3. So we add 3 here and it's 8, add 3 again and it's 11, and then one more time and it's 14. Who has questions on that? You good? All right, so for the people who were not in class, I do recommend that they click on the link that will be in Schoology here to read about how Carl Friedrich Gauss added these numbers from 1 to 100. And the formula that he came up with was this one here. So S is sum. So if you're trying to find the sum of the numbers, then you can add the first number and the last number, and multiply it by half the number of numbers. So adding the numbers from 1 to 100 would be 1 plus 100, and then 100 over 2 gives you 50. You multiply it by 50. Sometimes you don't know the last number though. So if I say I'm going to do this pattern where I start at 7 and I add 3 each time, and I want to know the sum of the first 100 terms, but I don't know what that last term is, then I can use this formula. It's more complicated, but you use this one when you don't know the last term. Use when you don't know the last term. Okay? Like in example 7. You see how in example 7 it says find the sum of the first 10 terms, and we don't know the last term. So let's do that one. We'll start it together, and then I'll give you a minute to work on it. So to find the sum, I need to know n, the number of terms. How many terms is it?
4.
It says find the sum of how many terms? 10 terms, okay? Find the sum of 10 terms. I need to know a sub 1. A sub 1 is the first term. What's the first term?
3.
A sub 1 is 3. Let's see. I already have n. I need to know d. D is, remember, how much we're adding each time. Now, you guys can mostly see that we're adding 4. But say it was harder. If it's harder, all you have to do is do the second one minus the first one to find that your d is 4. Okay? So now we know n is 10. First term is 3. D is 4. So I want you to use the second formula now to find the sum of the first 10 terms. All right, so let's see how you did. So we're going to put s sub n. Actually, you can write s sub 10 because it's the sum of the first 10 numbers. And then 10 over 2. That is going to be 2 times a sub 1, so 2 times 3, plus n minus 1, so 10 minus 1. And then times d, d is 4. And that's it, right? All right, so when you put that in your calculator, if you entered it correctly, you should get the right answer. You can also do it step by step. What answer are you guys getting? 210's right. If your calculator is not getting that answer for you, I can look at it with you and see how you might have entered it incorrectly. I'm going to show you the steps too. So this is 6 here, and then this is going to be 9 times 4, which is 36. So, and then this one is 5. So this is 5, this is 6, plus 9 times 4 is 36. And then 5 times 42 is how they get 210. But it's okay if your calculator did all those steps for you. You just needed to know how to substitute into the formula. All right, in example 8, they do give you the last number, so you can use the easiest formula, this one. So I want you to try now to identify n, a sub 1, and a sub n, and then use this formula to find the sum of this series. Notice they call it a series when you find the sum, and they call it a sequence when you're just trying to find the numbers in the pattern. All right, so to use this first formula up here, we need to know n, which we do know. N is 20 terms. And then we need to know a sub 1, which is the first term. And we need to know a sub n, which is the last term. And so to find the sum of the first 20 terms, I'm going to put n is 20 over 2 times the first plus the last. And I'm getting 1,270. Anybody else get that? You got that? Thank you. Okay, questions on that one? So we use the first formula. The first formula is easier, but you can only use it when you know the last term. All right, so here's a word problem where we use the arithmetic series. A theater has 32 seats in the first row, 34 in the second row, 36 in the third. If this pattern continues, what's the total number of seats in the first 15 rows? So, do we know the last term, a sub n? Do we know how many seats are in the last row? We don't. You could find it out using the patterns from the front, but we don't know how many seats in the last row, so we're going to use this one, okay? So we're going to find the sum of, this is what's the total number of seats in the first 15 rows, so total is sum. Sum of the first 15 rows, and n over 2, so n is 15 rows, 2 times the first row, so the first row is 32, plus n minus 1, so 15 minus 1, times d. Oh, how much is d, guys? Why is it 2? 34 minus 32, good. So d is 2 because we're going up 2 seats each row. And you can also find it by subtracting the second one minus the first one. So d equals 2 seats. So I'm going to do times 2. Okay, if you haven't calculated that yet, go ahead and calculate it and we'll see if we get the same answer. Okay, are you guys getting 690?